Hello students, in this class we will learn how we can solve some special kind of arithmetic problem. Okay, here we choose these four problems. In the first problem, the nth term of an AP is given, which is in the form of n. From this given relation, we have to find the common difference of this AP. Okay, in the second problem, sum of nth term of an AP is given, which is also in a relation with n. From that relation also we have to find the 15th term of the AP. Okay. In the third problem, an AP is given and we have to find 10th term of that AP from the n. In our previous classes, we learned about how we can find the nth term of an AP, and that nth term is from the beginning. Okay, but in problem number 3, we have to find the nth term, the 10th term of that AP from the n. So we will learn how we can find some number of terms or some say nth term from the end of an AP. Okay, and in the fourth problem, there is a relationship between some terms are given, and by applying those relations, we have to find or we have to prove that if the m plus nth term of that AP is 0. Okay, so these four problems are different kinds. So let us study how we can solve these kind of problems. Okay. Solution 1. If nth term of an AP is 2n minus 3, then find the common difference of the AP. Given is nth term of the AP is denoted by an. An is equals to 2n minus 3. We have to find the common difference of that or of the AP. Okay. So n equals to 2n minus 3. Now if we put n equals to 1, then we will get a1. If we put n equals to 2, then we will get a2. If we put n equals to 3, then we will get a3. This way we can find the terms of that AP. Okay. So now putting n equals to 1, 2, 3 in the above relation, we get a1 equals to 2 into 1 minus 3. So this implies a1 equals to 2 minus 3, imply a1 equals to minus 1. When we put n equals to 2 in this relation, then we get a2 equals to 2 into 2 minus 3. This implies a2 equals to 4 minus 3, imply a2 equals to 1. When we put n equals to 3, then we will get a3. a3 equals to 2 into 3 minus 3. This implies a3 equals to 6 minus 3. This implies a3 equals to 3. Okay. So the AP becomes -1, 1, 3. Continuing. Therefore, common difference equals to, when an AP is given, then to find the common difference, we have to find any term minus its previous term. Okay, that means A2 minus A1 will give common difference. Similarly, A3 minus A2 will give common difference. So A1, A2 minus A1, that is 1 minus of minus 1. 1 plus 1 equals to 2. Or A3 minus A2 equals to 3 minus 1 equals to 2. So this implies common difference equals to 2. So this is a kind of problem where nth term of an AP is given, with that nth term is also in terms of n. So from this relation, by this way we can find the common difference of that AP. Okay. In problem number 2, sum of n terms of an AP is given. That sum is also in terms of n. Okay. So from this relation, we have to find the 15th term of that AP. Okay. So to find any term of that AP, we have to know the first term and the common difference of that AP. That is why from this relation, from the given relation, Sn equals to 5n square plus 3n. First of all, we have to find the first term and common difference of the AP. Okay, so let us study how we can find the first term and common difference of that AP. Given Sn equals to 5n square plus 3n. We have to find fifteenth term of that AP. To find the 15th term, that is A15 of that AP, we have to know the first term A1 and common difference of that AP. Okay, so Sn equals to 5n square plus 3n is given, where Sn denotes sum of n terms of an AP. We have to find 15th term of that AP. So to find the 15th term of that AP, first of all we have to know its first term, that is A1, and common difference D of that AP. Okay. So let us study how we can find the first term and common difference from this relation. Putting n equals to 1 n for putting n equals to 1, 2, 3 in the above relation, we get S1 equals to 5 into 1 squared plus 3 into 1. So this implies S1 equals to 5 into 1 plus 3. That is 5 plus 3 equals to 8. S2 equals to 5 into 2 square plus 3 into 2. Imply S2 equals to 5 into 4 plus 3 into 2, 6. This implies S2 equals to 20 plus 6. Imply S2 equals to 26. Putting n equals to 3, we get S3 equals to 5 into 3 square plus 3 into 3. This implies S3 equals to 5 into 9 plus 9. This implies S3 equals to 45 plus 9. This implies S3 equals to 54. Okay. So after putting n equals to 1, 2 and 3 in this relation, Sn equals to 5n square plus 3n, we get S1 equals to 8, S2 equals to 26 and S3 equals to 54. So A1 equals to S1 imply A1 equals to 8. S1 means sum of one terms. That means S1 represents first term of that AP. That is why we can write A1 equals to S1. This implies A1 equals to 8 because S1 is 8. S2 equals to 26 imply S2 means sum of first two terms of that AP, that is A1 plus A2 represents S2, that is why we can write A1 plus A2 equals to 26. Since A1 equals to 8, then 8 plus A2 will give 26. This implies A2 equals to 26 minus 8. This implies A2 equals to 18. S3. S3 means sum of first three terms of that AP. That is S3 equals to A1 plus A2 plus A3. So this implies S3 equals to 54. Imply S3 means sum of first three terms of that AP, that is A1 plus A2 plus A3 equals to 54. So this implies A1 means 8, A2 means 18, that is 8 plus 18 plus A3 equals to 54. This implies 26 plus A3 equals to 54. This implies A3 equals to 54 minus 26. This implies A3 equals to 28. Okay. So from these three direction S1, S2, S3, we find first term A1, second term A2 and third term A3 of that AP. So now the AP becomes first term 8, second term 18, third term 28, continuing. This is an AP because 18 minus 8 will give 10. 28 minus 18 gives 10. That is, any term minus its previous term gives a fixed value. So, common difference equals to A2 minus A1 equals to 18 minus 8 equals to 10. Common difference D equals to A2 minus A1 equals to 10. So, for this AP, the first term A1 and common difference D now known to us. That is why we can find its 15th term. So, therefore, 15th term of that AP, A15 equals to A1 plus 15 minus 1 into D. By following this general formula, already we know this general formula. An, that is nth term, is equals to A1 plus n minus 1 into D. So, by this formula, A15 is equals to A1 plus 15 minus 1 into D. This implies A15 equals to A1. A1 means 8 plus 15 minus 1 means 14 into D. D means 10. This implies A15 is equals to 8 plus 140. This implies A15 equals to 148. This is our required value. So, this is the way by which we can find any term of an AP when its nth when sum of its nth term is given in terms of n. Okay. Solution 3. Here an AP is given. The AP is 8, 10, 26, 8, 10, 12, 126, continuing. We have to find the 10th term of that AP from the n. Okay. In our previous classes, we learned about how we can find the nth term of an AP. That nth term of that AP is from the beginning. Okay. But this problem is different from that previous problem because here we have to find the 10th term of that AP from the end. Okay. So, let us study how we can find the 10th term of how we can find any number of term of that AP from the end, and that number of term how is related with that with same number of term from the beginning. Okay. Here we choose an AP 2, 4, 6, 8, 10, 12, 14. So, this is an AP. Third term from the end is equals to 1, 2, 3. This is the third term from the end, and that is 10, and this third term from the end is equals to 1, 2, 3, 4, 5. Fifth term from the beginning. Okay. Fifth term from the beginning, which is equals to which is equals to 7 plus 1 minus 3 eighth term from the beginning, where 7 is the total number of terms of the AP. Okay. So, by this way, we can create a relationship between the terms of an AP. That is some number of terms. Say here third term from the end is equals to which number of term from the beginning of that AP. Similarly, second term from the end. Second term from the end is 12 is equals to 1, 2, 3, 4, 5, 6. Sixth term from the beginning, that is also 7 plus 1 minus 2. Eighth term from the beginning. Okay. So this relation also follows for the second term from the end. That is why in general if an AP contains n terms, then pth term from the end is equals to n plus 1 minus p th term from the beginning. Okay. So this is the general way. That means if an AP contains n terms, then pth term from the end of that AP is equals to n plus 1 minus p th term from the beginning. Okay. So this is the concept. Depending upon this concept, we will find the 10th term of that AP from the end. Okay. There is another way. Another way means without this concept, we can also find the 10th term of that AP from the beginning. Okay. So that concept we will study after solving this problem by using this formula or general form. Given AP is 8, 10, 12 continuing up to 126. Okay. So first of all, we have to find the common difference and the total number of terms of this AP by using this formula. Sorry, first of all we have to find the common difference and the total number of terms of this AP to find the 10th term of that AP from the N to use this formula. First term A1 equals to 8. Common difference D equals to 10 minus 8 equals to 2. Let nth term of the AP be 126. So therefore, AN equals to 126 implying A1 plus n minus 1 into D equals to 126. This implies 8 plus n minus 1 into 2 equals to 126. This implies n minus 1 into 2 equals to 126 minus 8. This implies n minus 1 equals to 118 by 2. This implies n equals to 59 plus 1. This implies n equals to 69. So, the AP contains 60 terms. Therefore, 10th term from the end of that AP equals to 60 plus 1 minus 10. 8th term from the beginning equals to 60 plus 1, 61, 61 minus 10, that is 51. That is 51st term from the beginning equals to A51 equals to A1 plus 51 minus 1 whole into D equals to A1 means 8. 8 plus 50 into D. D means 2. This implies A51 equals to 8 plus 100. This implies A51 equals to 108. Okay. So this is the way by which we can find the 10th term from that AP from the N, or sorry, 10th term of that AP from the N. Okay. There is another way by which we can also find the 10th term of this AP from the N. Another way to find 10th term of that AP from the end. For this, we have to consider the given AP from the end by the following way. One 26, 124, continuing 12, 10, 8. Okay, so this is the another way by which we can find the 10th term of that AP from the end. So for this, we consider this given AP from the end. That is, its last term is 126 and second last term is 124 because common difference is 2. That is why when we consider that AP from the end, then it becomes 126, 124 continuing 10, 12, 10, 8. So A1 equals to 126. Common difference D equals to 124 minus 126. That is minus 2. So therefore, 10th term equals to A10 equals to A1 plus 10 minus 1 into D. That is 126 plus 9 into minus D. That is 126 minus 18 equals to 108. This is also 108 and this is also 108. That means in both of these cases, the 10th term of the AP becomes 108. Okay. So this is another way by which we can find the 10th term of that AP from the end. Okay. So according to me, this is the best way. That means by this way, when we want to find some number of terms of an AP from the end, then this will be the best method. Okay. In problem number 4, it is given that m times the mth term of an AP is equal to n times its nth term. That means a relationship between the terms is given. Okay. So from that relation, we have to show its m plus nth term is 0. So to find any term of an AP, we have to know the first term and the common difference of that AP. That is why first of all we have to let the first term and the common difference of that AP. Given m times the mth term. M times the mth term means am is equals to n times the nth term. Okay, this is given. Let first term and common difference of the AP be A and D respectively. So first term A1 becomes A and common difference is D. Now we have to show its m plus nth term is 0. That is, a of m plus n is equals to 0. Okay. So we have to show this thing, that is a of m plus n is 0. That is, m plus nth term of that AP is 0. So now from the given we have m into am, that is m times of mth term is equals to n times its nth term. M into am means first term plus, that is a plus m minus 1 into d is equals to n into first term a plus n minus 1 into d by this formula. Since x term of the table, that is ax equals to a1 plus x minus 1 into d. Here we choose a1 as the first term as a and common difference is d. So after multiplying these we get ma plus m into m minus 1 into d is equals to na plus n into n minus 1 into d. Now we can bring these terms in the left hand side by subtracting, and after arranging we will get ma minus na plus multiplying this we get m square minus m whole into d, and when we bring this thing in the left hand side then this will be minus, and after multiplying n with n minus 1 we will get n square minus n, this whole into d equals to 0. We can take a as the common factor. After taking a as the common factor we get a into m minus n, and from this last two term we can take d as the common factor, and after taking d as the common factor we get m square minus m minus of n square minus n, this whole into d equals to 0. A into m minus n plus d into m square minus m minus n square, this minus into minus becomes plus n, this whole thing into d equals to 0. A into m minus n plus d into, now we can arrange these squares, that is m square minus n square minus m plus n whole into d equals to 0. So a into m minus n plus d whole into, we can use a square minus b square identity, and by using that identity we get m square minus n square as m plus n into m minus n. By using this identity, a square minus b square equals to a plus b into a minus b. by using this identity, we can write m square minus n square as m plus n into m minus n, and then we can take minus 1 as the common factor from this last two terms, that is minus m plus n. After taking minus 1 as the common factor, we get minus 1 whole into m minus n. This whole thing into d equals to 0. So a into m minus n plus d whole into. Now we can consider this as a term and this thing as a term. From these two terms, we can take m minus n as the common factor. So after taking m minus n as the common factor, we get m minus n whole into. In the first term, the rest of the term is m plus n, and in the second term, the rest of the term is minus 1. This whole thing into d equals to 0. Sorry, there will be only one d. So this imply a into m minus n plus d into m minus n into m plus n minus 1 equals to 0. Okay. Now this is a term and this is another term. From these two terms, we can take m minus n as the common factor. And after taking m minus n as the common factor, the rest term becomes a plus d into m plus n minus 1 equals to 0. Now product of m minus n and a plus d into m plus n minus 1 equals to 0. Product of these two terms equals to 0. So we can choose this equals to 0 and this equals to 0, or both of these equals to 0. But if m minus n equals to 0, then we will get m equals to n, that is number of terms are equal, which is not possible because m and n are two different number of terms of that AP. Okay. That is why we can write a plus d into m plus n minus 1 equals to 0, because m minus n equals to 0 imply m equals to n, which is not possible as m and n are two different number of terms of this AP. That is why we cannot consider m minus n equals to 0. So this will give a plus d into m plus n minus 1 equals to 0. This implies a plus, that means after arranging this, we will get a plus m plus n minus 1 whole into d equals to 0. So this is the m plus nth term. Hence, the result should. Okay, so this is the way by which we can prove the m plus nth term of that AP is 0.